Hello? In the next few minutes, you'll discover how psychologists turn ideas into solid proof. We'll break down the experimental method step by step to show you how researchers find cause and effect answers from questions. An experiment is like a recipe for discovering the truth. You change one thing called the independent variable, or IV, and observe how it affects another thing called the dependent variable, or DV. Let's think about this example. You want to test if students focus better under bright lights or dim ones. Your independent variable is the lighting, bright versus dim. Your dependent variable is attention, maybe measured through a concentration quiz or test scores. Simple enough, right? But hold up. In real life, there are always other factors that could interfere. These are known as extraneous or uncontrolled variables. For example, maybe some students are hungry, tired, or just had a fight with their roommate. These factors could affect attention regardless of lighting. To reduce this interference, researchers try to keep all other variables controlled. But how? We create order. First with standardization, which means that we keep everything else the same. Same room, same instructions, same timing. What else helps? A control group. A control group is a set of participants who don't get the change. Maybe they just study under normal lighting. This gives us something to compare against. Still, even the best setups need a trial run. That's where the pilot study comes in. A pilot study is a mini version of the experiment to catch problems early before the real test begins. But why go through all this effort? We seek the truth. Our goal is a valid study. We need to ensure we're measuring what we intend to measure. It must also be reliable, meaning if repeated, the results should be consistent. Let's simplify it. Checkpoint. The truth test. Let's begin with internal validity. Was the IV the reason for the DV change? Was the experiment designed correctly? If yes, we have internal validity. Now think about the real-world impact. That's what we call external validity. Consider if your results work in real-world settings. Does your experiment resemble everyday situations? This is known as ecological validity. Can your findings be relevant to various people? This is known as population validity. We also focus on reliability. Do results stay consistent every time? When you repeat the experiment, are the results the same? How do we check reliability? We use tools like replication. This means repeating the experiment to check if you achieve the same results. Next is inter-rater reliability. Here, different researchers compare notes to see if they agree on the results. Finally, there's test-retest, where you administer the same test twice to ensure the responses are consistent. Here's a brief summary. We aim to improve accuracy and consistency by revisiting key concepts, standardization, control groups, and pilot studies. We have established our variables, framework, and a plan to ensure fairness and repeatability. Yet we still face one crucial question: who will receive each condition? Imagine you're testing bright and dim lights. How do you decide who gets each one? This is where experimental designs come in, the plan for assigning participants to groups. The first option is independent measures design. Here, each person tries only one version. For example, one group gets bright lights, the other dim. This avoids practice effects or boredom from repetition. But there's a risk. Groups are different. Some might focus more, which is a participant variable. We use random allocation to address this. This involves placing people in groups randomly to balance differences. Another way is using the same people again, called repeated measures design. Picture this. A repeated measures design is like getting to double dip. Everyone gets to try out both conditions. In our example, it's all about the super bright and the mysterious not so bright vibes. We get to have a blast comparing everyone to their own past selves. This smart move clears out the differences and gives us super clear info. It's a handy way to deal with those quirky individual traits. But here's a twist, those pesky order effects. Doing both tasks can lead to order effects, where folks might turn into pros with practice or just lose steam like a flat soda because of being tired. To address this, we implement counterbalancing. Half the participants start with condition A and then move to condition B, while the other half begins with condition B, followed by condition A. We also have another method, matched pairs design. Participants are paired based on key traits like age or IQ, and each pair is split across the two conditions. This approach helps balance their abilities. Though creating this design takes effort, blending elements requires precision and care. It's challenging to align people perfectly. This is why studies explore identical twins. They share the same genetic makeup and background, forming a nearly magical match. As your design concludes, a new choice awaits. What path will you take next? Will you enter the tidy, controlled world of a lab, or step into the chaos of real life with a field experiment? Lab experiments. Control and replication. Lab experiments take place in a controlled space, like a research room. They help us manage variables and repeat processes easily. It sounds ideal, right? But there's a downside. Labs can feel unnatural, so people might not behave as they would in real life. This is called low ecological validity. What if we want natural behavior? We turn to field experiments in real-world places like schools or stores. People act more naturally, enhancing ecological validity. But field experiments have their own challenges. They are harder to control and ethical issues can arise. Getting informed consent is tricky when participants aren't aware they're part of a study. So, which is preferable? Lab studies with control or field studies with realism? The best option depends on your objectives. We've prepared our experiment, so let's create a hypothesis, which is a prediction we can test. It's like making a guess that we can check. What types of hypotheses exist? The first type is a non-directional hypothesis, also called a two-tailed hypothesis. This predicts a difference without saying if it's positive or negative. Consider this. There's a potential difference in test scores between students using mind maps and those using revision apps. We are uncertain which is superior, only that a difference exists. But what if we believe one option is superior? Then we have a directional hypothesis, also known as one-tailed. This not only predicts a difference, but also its direction. For example, we believe that students using revision apps will outperform those using mind maps. Last, we have a null hypothesis when there's no difference. This means any changes happen by chance. It's like saying nothing changes. Here's a key point. Your hypothesis needs to be testable. It should have a clear way to be proven false. If it can't be disproven, it doesn't count as scientific. Let's keep going. Essential rule: ensure participant safety. Remember, nothing is worth causing harm to others. Psychologists must safeguard their participants. This involves adhering to essential ethical principles. Informed consent. Participants must understand the study and agree to join. No surprises, people need to choose freely. What if they change their mind? Let's talk about right to withdraw. Participants have the right to leave the study anytime for any reason. What else must we protect them from? Researchers must keep participants safe from harm, avoiding stress, pain, or fear. The study should feel safe. What about personal details? We must honor their privacy, which involves keeping data secure and confidential. This is crucial in lab or field studies. However, can researchers truly maintain secrecy? Let's discuss deception and debriefing. Sometimes scientists use deception to keep results genuine by not revealing everything up front. However, they must give a complete explanation during the debriefing. In field research, obtaining full consent can be tricky, as people might be unaware they're part of a study. Yet researchers have a duty to ensure their safety and prevent any harm. Research seeks answers while respecting people. Ethics and science must coexist in psychology. Ready to design your study? Here's what you'll need. Identify your independent and dependent variables. Choose your experimental design, independent, repeated, or matched pairs. Decide on the location, lab or field experiment. Craft a clear, precise hypothesis. Control extraneous variables. Ensure adherence to ethical guidelines. Ensure the study's validity and reliability. Thank you for being part of this journey into the experimental method. Whether you're preparing for tests, catching up on your studies, or just curious about how science works, you now have the guide. See you later. Goodbye.